Hello, I'm Andy RC, and you might learn something today. I think the word might is a lot more British, don't you think? Anyways, today I'm going to be checking out the FURC Insaneya 4S batteries. Yes, I know there are 8 cells here, but they are actually wired in parallel, which essentially gives us a 1600 milliamp 4S. They're actually 2 Tattoo 800 milliamp batteries bolted together. I believe they've worked in conjunction with Tattoo here. So why would you want to do this? Well, you can see written on the side there, C rating, and then an infinity symbol. Now, of course, in reality, that's not true, but I'll explain the thinking behind this. So we're seeing a lot of racers go to lower kV motors and 6S batteries. I've talked about it before on the channel. And this is to cope with voltage sag. So as you go up in volts, the current draw is less, and therefore your battery sag is less. And battery sag is bad for a lot of reasons, such as it reduces the life cycle of the battery. But something I found with my speed test is that you actually lose performance and speed. For example, if a 4S drops to 13 volts under load, it's not going to be given as much thrust or as much speed as it could be at 15 volts under load. The thing is though, thrust isn't that important. For racers, you're never going to reach the max speed of a copter on a race circuit. It's actually quite hard to do that because most racetracks are close to the ground, and in order to go between gates quickly, you have to have a lot of angle on your copter, and I found that a quadcopter isn't at its quickest at an extreme angle. It's actually quicker gaining a slight altitude. And I've seen some of you racers going up high between gates. I know what you're up to. And most copters on full tilt, from my experience, they usually max out at around about 88 miles per hour, and there's a Back to the Future joke in there somewhere, I'm sure. But that's what I found from my tests. Anyways, I tend to find that the rotors start to act as a brake at a high angle because of the drag. So the biggest problem for racers is endurance. So on a 4S battery, you can potter around until your battery reaches around about 14 volts. But trying to go full throttle at 14 volts will do a lot of damage to the battery, and you'll also have next to no power. And that's the biggest problem for racers, because they have to come off the throttle in order to complete the end laps of a race, for example. So the thinking behind this battery is that the voltage sag is spread across more cells, and it will sag less than a normal 4-cell battery. So I bought this from AirJacker at the mini air show on Saturday, and I think I paid $26.99 for it, which is about the same price as what I'm going to be comparing it to, which is the Tattoo R-Line 1300 milliamp 4S. I guess a proper test would be trying the Insaneya battery against something like a 1500, because doing these speed runs I've actually realized that capacity is really important as well. If we look back at a previous speed run that I've done, a 1000 milliamp 65C 4-cell Turnigy graphene battery had a much larger sag than a Tattoo 1300 milliamp 100C battery, and that is because C is capacity. So 1000 milliamp times by 65 is only 65 amps, whereas a 1300 milliamp battery times by 100C is 130 amps. And that's why the copter performed better despite it being a heavier battery. So a better comparison would perhaps be the Tattoo 1550 milliamp 4S, which can deliver 155 amps, but these Insaneya batteries have an infinity C rating, right? So there should be no sag at all, and any battery I throw at it should get blown away by it, surely. I do have some other 1500 milliamp batteries, but they aren't new, and of course these are, so I want that aspect to be fair, because I have identical batteries, new and old, and the new ones perform way better than the old ones. So the difference with this Insaneya battery needs to be fairly marginal, because it's only going to get worse from here as it has more cycles put through it. And of course the longevity of this battery is only something that I can test over time. So it weighs 198.5 grams against the 163 grams of the R-line. By the way, these are the high volt R-lines, but you don't have to run them at high volt. They will last longer with a normal charge. Now I'm going to be cruel and reuse this amp hungry mode 2 build from the previous video, which I'll link to in the below if you want to check out the specs, because that makes a difference as well. So let's get and see the results. Now, this copter doesn't have a current meter, and I know I'm going to get some stick for that in the comments, but I never find those to be very accurate anyways, and what I'm interested in is the voltage sag and also the thrust difference. So the R-line on full throttle sagged to 13 volts when it recorded its quickest speed of 101 mile per hour. With the Insaneya battery, it sagged to 13.5 volts, which is definitely not infinity, is it? I will say, though, that it felt quicker through the goggles, and what I mean by that is that there was more instant punch there, and the power felt a little bit more consistent. It's something really that a speed run or a thrust test can't really tell you. What's interesting about that, though, is the speed runs do tell a different story. The R-line, although it gave an initial slower speed, it gave more consistent speeds than the Insaneya throughout the flight, and I was able to replicate that as well with a second battery because I bought two of them. So the initial speed run for both of the flights was 102 mile per hour, but that quickly tailed off into the low 90s, and the R-line actually maintained a higher speed throughout the entire flight. So, coupled with the fact that the Insaneya is a higher capacity, I can't say that it was too much of a benefit. Now, I understand that this is an amp-hungry model and it might perform differently on another setup. And, of course, this is extreme stress testing here as well. So, the Insaneya did do better when it came to flight time. Now you have to bear in mind that this is an ultralight, and with average aqua flying I could get over a 7-minute flight time, which sounds good, doesn't it? But with the 1300 milliamp battery, that also gave over a 6-minute flight time. So on a heavier model, I think those margins are going to be even narrower than that. So, to conclude, I actually don't think the Insaneya battery is doing a much better job than a top-line 4-cell battery of a similar capacity. I'd love to know your comments on why you think that is. You know, I'm not the most technical person when it comes to batteries, but I do know that there are just so many variables with this stuff. You see, the advantage of running a 6S is not to spread the load over the cells, it's for a lower current draw. And my guess would be that when running batteries in parallel, the accuracy of the internal resistance of each cell becomes more important. So yeah, we do have more cells to spread the load of the voltage sag, but we also have more cells that might not be identical to each other, and that means that the other cells have to compensate, and there's definitely going to be some losses there, I think. And I do think that the 35-gram difference between the two batteries is going to play a factor, especially on an ultralight, but technically the C rating of the Insaneya should be higher than the 1300. So I expect more thrust and less amp draw, and that was actually the case, but only by a very small margin. And I have a feeling that the Tattoo 1550 milliamp battery could very well match that. Oh, by the way, if you are running a top mount, then this isn't going to fit unless you have it sat really tall. Other than that, it's really just for a bottom mount only. Most battery straps won't fit around it either because, you know, they are designed for a 4S, so I've used this ghetto flame wheel strap here. And for the best performance, I found that it recorded the best speeds on its side. It actually recorded lower top speeds mounted normally, but that's more down to the fact that quadcopters are faster at a slightly flatter angle, as mentioned earlier, so the big block hanging down at the bottom there causes drag at lower angles. That's my theory anyway. So you get one of these balance port protectors, which I never use. Now, I was trying to understand how a battery like this would balance, so I turned to my friend NJ who has a lot more experience when it comes to batteries in this configuration. I think he said in his Halley days he was using a 6S8P. So this is a 4S2P, 4 being the number of series cells in the pack and P being the number in parallel. And NJ very kindly made me this drawing because I was struggling to get my head around it. So each wire of the balance port is connected after the 2 individual cells that are in parallel, and therefore it can balance each cell. So thanks to NJ for explaining this, and please get and subscribe to him if you are not already. And there you go. If you found this video useful, I'll link to my Patreon in the below. And as always, thanks so much for watching. Please continue to subscribe. Cheers.